So y is equal to 69 divided by tan 22 degrees, which is equal to 170.78. That's the first distance that we solve between the first boat from the lighthouse. So we have 170.78. But that's not the final answer. We need to solve for the whole distance between the lighthouse and the boat. So we're going to solve for the distance which stands for x. The same trigonometric ratio, we're going to use tangent. Tan 48, which is equal to the opposite, which is 69 degrees, and 69 feet, divided by x. So tan 48 degrees times x equals to 69 feet. Divide both sides by tan 48. So x is equal to 69 divided by tan 48, which is equal to 62.13 feet. So we are done in solving for the distance between the two boats that the observer have seen from the lighthouse. So to get the total distance from the lighthouse for both boats that we have, so add 62.13 feet plus 170.78 feet. So the total distance from the lighthouse, the boat, is equal to 232.91 feet. So that is the distance from the lighthouse of the two boats that we have from that the observer have saw in the lighthouse. Question in this example that we have. Okay na? Can I clear the screen? Okay na for this example? For example, we have this word problem. A pilot flying at an altitude of 12,000 feet sights two airports directly in front of him. The angle of depression to one airport is 78 degrees, and the angle of depression to the second airport is 19 degrees. What is the distance between the two airports round to the nearest foot? So the same of what we have a while ago. We're going to solve for a two distance of an airport from a plane. So let's say that the pilot is flying from an altitude or height of 12,000 feet. This is where the plane is. The first airport that he saw has an angle of depression of 78 degrees. That's the first angle of depression, or the first airport that the pilot have saw. And he saw a second airport that has an angle of depression of 19 degrees. So So let's say this is airport A and airport B. So since this is 78 degrees, that means angle A has also a degree or angle of 78 degrees. And we have angle B that has a measure of 19 degrees also, given from the angle of depression. So we're going to solve for the distance between the difference between the distance between the two airports that we have. So let's say this is y and this is x. The distance, you're going to solve for the distance that stands for y and the distance that stands for x. So let's solve for y first. So tan, since we're solving for y, we're going to use the 78 degrees angle of depression. So tan 78 equals to 12,000 feet divided by the y we're going to solve. So tan 78 times y equals to 12,000. Divide both sides by tan 78. So y is equal to 12,000 divided by tan 78, which is 2,550.7 feet. So that's the distance of the first airport to the airplane. So let's solve for the second airport, the distance of the second airport to the plane. So let's solve for x. So tan 19 degrees equals to 12,000 divided by x. That stands for the distance between the plane and the second airport. So tan 19 times x equals to 12,000. Divide both sides by tan 19 degrees. So we have x is equal to 12,000 divided by tan 19, which is equal to 34,850.5 feet. So that's the two distance between the two airports that we have from the airplane. So the total distance of a plane to both of the airports that we have in the problem is 34,850.5 feet plus 2,550.70 feet, which is equal to 0.5 plus 2,550.7, which is equal to 37,401.2 feet. So that's the total distance that we have from the airplanes between the two airports that we have. Now, for this example, can I clear the screen? Na. For example, we have this word problem. A plane is flying at an altitude of 14,500 feet. The angle of depression from the plane to a control tower is 15 degrees. What is the horizontal distance from the plane to the tower round to the nearest foot? Let's draw this word problem that we have. It says here that a plane is flying in an altitude of 14,500 feet. That's the height of the plane that is flying from the tower. And it has an angle of depression which is equal to 15 degrees. So let's say this is the tower. It has an angle of depression which is 15 degrees. And we're going to find the distance between the plane that is flying from the tower. So we're going to solve for this side of the triangle. The distance between the plane and the tower. So since the angle of depression is 15 degrees, using the concept of transversal angle, that means this angle is also equal to 15 degrees. So let's say we're going to solve for the x, the distance between the tower and the plane. So we're going to use trigonometric ratio, tangent, 15 degrees equals to the opposite side. Opposite side has a measurement of 14,500 feet over the adjacent side. Stands for x. So tan 15x equals to 14,500 feet. Divide both sides by tan 15. So the distance between the plane and the tower is equals to 14,500 divided by tan 15, which is equal to 54,114.7 feet. So more on in a word problem in the angle of elevation and depression, the trigonometric ratio that we're going to use is more on tangent. Tangent lagi ang ginagamit for the angle of depression and angle of elevation, whatever problem it is. So we have 54,114 or 54,115. Solve the second problem that we have here. It says here, a woman is standing 12 feet from a sculpture. The angle of elevation from her eye to the top of a sculpture is 30 degrees. And the angle of depression to its base is 22 degrees. How tall is the sculpture to the nearest foot? Let's draw. Draw this problem that we have. Let's state that a woman is looking at a sculpture. A woman who is standing with the height. This is the height of the woman, which is 12 feet. Is looking at the sculpture with the angle of elevation, which is that has a degree of 30 degrees. That's the angle of elevation. have 30 degrees. And a woman is standing 12 feet from the sculpture. And the depression, an angle of depression to its base, which is 22 degrees. Say this is the woman. Say A is the woman. This is where she's standing. And the sculpture is 12 feet far from the woman that we have. Angle of depression, it has 30 degrees. 22 degrees. This is angle of elevation. The sculpture is here. Let's say this is the sculpture, stands for B. Angle of depression from its base is equal to 22 degrees. So we're going to solve how tall does the sculpture to the nearest foot. So that means we're going to solve for this one. Let's say this is x, the height of the sculpture from the woman who is looking at the sculpture. So since we have the angle of elevation, which is 30 degrees, and the angle of depression, which is 22 degrees, we can either use the angle of depression or the angle of elevation. Let's use the angle of depression. The angle of elevation. So tan 30 degrees, that's the angle of elevation. And we have the opposite angle, which is equal to x. And the adjacent angle, which is equal to 12 feet. So tan 30 degrees times 12 is equal to the height of the sculpture. So tan 30 degrees times 12 feet, which is equal to 6.93 feet. So that's the height of the sculpture from its base. Question and solving for the angle of elevation and angle of depression. Okay, let's have one last example for the angle of elevation and angle of depression. Okay, so let's say a tree that has a height of 9 feet and a man looking at the tree say this is the tree, this is the ground, and this is the man. The man is looking at the tree that has formed an angle of elevation which is equal to 15 degrees. And we're going to find the distance between the tree and the man that is standing. We're going to solve the horizontal distance. The distance between the tree and the person who is looking at the tree. The side of the triangle, the distance. So tan 15 degrees equals to the opposite side, which is 9 feet, divided by the side, which stands for x. So tan 15 degrees times x is equal to 9 feet. Divide both sides by tan 15 degrees. So x, or the distance between the tree and the person, is equal to 9 divided by tan 15 degrees, which has a measurement of 33.59 feet. So that's the distance between the tree and a person looking at the tree. It has an angle of elevation of 15 degrees and the height of a 90. The height of a tree, which is 90. Okay. So for tomorrow, we're going to have an activity regarding with the angle of elevation and angle of depression. We're not going to have a quiz tomorrow, even though it's Friday. We're not going to have a quiz. We're just going to have an activity tomorrow for angle of elevation and angle of depression. Okay? So, since we are done discussing about angles of depression and elevation, I think that will be all for this afternoon. Goodbye, everyone, and see you tomorrow.
Bye.